In this video, we are going to do these 1, 2, 3, 4, 5, 6 questions. Few of them are from definite integrals, others are indefinite integrals. And we also be using these two properties of definite integrals for solving this question. The question here is to find the integration of dx over x multiplied by x raised to the power 7 plus 1. So we will be applying substitution, and in substitution we'll be taking x raised to the power 7 as t. That results to give you, on differentiating, it is 7x raised to the power 6 dx is equal to dt. So clearly we need a 7 over here. So I will be equal to, I can write this as I. What I'm going to do is to first multiply and divide it by 7. I'm also multiplying the numerator with x raised to the power 6 and this denominator, that is x, right? X multiplied by x raised to the power 6 should give you x raised to the power 7, and inside the bracket it is x raised to the power 7 plus 1, that's dx. This is 1 over 7. What I can write over this, can I replace this whole thing with the dt? Right, that should become dt. And below you can see this is t multiplied by t plus 1. Now we can apply partial fraction over here. So what I can say that 1 over t that multiplied by t plus 1, using partial fraction, I can write this as a over t plus b over t plus 1. So that results to give you, this is 1 is equal to a times t plus 1 plus b times t. So I can see placing t as 0, I'm getting a as 1, and placing t as minus 1, sorry, t as minus 1, I'm getting b as minus 1. So I can rewrite this, I is equal to 1 over 7 integration a over a is 1, right? So 1 over t minus b, and b is what? B is minus 1, right? That's why I placed a minus over here, and this is t plus 1. This is dt and a dt over here. Now next step is to write its integration. We know that 1 over t is what? Log t, log mod t, and I'm going to replace t with what I have taken as x raised to the power 7. So this is x raised to the power 7, and then there is a minus sign, 1 over 7 again, and this is log t, log mod t plus 1, right? T plus 1, that is x raised to the power 7 plus 1. Well, I can see that we can even apply some properties of log over here. So let's do that also. So this is I is equal to, if I take 1 by 7 as common, I can say it is in the form of log A minus log B, which is what? Log A over B, that is log x raised to the power 7 over B is what? X raised to the power 7 plus 1. And plus C should be here also. So this should be our final answer. In the next question, we have to find the value of this. Now, we will not be using substitution, as you know that if I take cos x as t, this is going to be dx, which is not in the form of product. So instead, we will be splitting this. Let's say if I split I is equal to, this is 2 times secant square x. So I can write 2 outside, that's better. 1 over cos square. Let me show you in one more step. This is cos square x, and minus 3 times, this is sin x over cos square x dx, dx over here as well. Now check what we can do. This is secant square x, right? This is secant square x minus 3 times. So what is sine over cos? Sine over cos is tan, and 1 over cos, we have 2 cos, right, in the denominator. So 1 cos can be written as secant x, and sine over other cos will give you tan x dx. So next is what? We know that integration of secant square x is what? Tan x minus 3 times integration of secant x into tan x. Sec x into tan x is what? Tan x. Oh, sec x. This is secant x plus c. Yeah, that's much only. The next one is this. We have to find the integration of this. Now, this can be asked in a 2-marker question. Could be an MCQ 1 mark. So we are just going to open this bracket. So that should give you what? This is, so to give you secant x into secant x is secant square x dx, and I'll write it separately, right? The other at secant x into tan x dx. So same as the previous question. Now we can write secant square x as what? Tan x, and the other as secant x into tan x is what? Secant x plus c. That should be the final answer. The next one is to evaluate this is a definite integration, and we have a modulus function as x cubed minus x. But the first thing which I do in such a case is to factorize this. This is x cubed minus x. So I can take x common, that will give you x squared minus 1 on further factorizing as a plus b into a minus b. So check from here, on equating with 0 we get minus 1, equating this with 0 we get 0, and equating this with 0 we get positive 1. And check for the limit here, it's minus 1 to 2, so 2 should also be included over here. Now once we found the limit over here, next thing we are going to do is to check the sign of these function, the function over here on the different values of x or different limit. So we have x cubed minus x, right? If I split this function, I'm not splitting, I'm rewriting this function for x belonging to minus 1 to 0, right? So that is x greater than minus 1 and for less than 0 in this limit. What we are going to get the sign of this. So you can either plug in the value anywhere over here, or maybe the function which I got, x minus 1, x plus 1, depending upon how you find easy. So you can even plug in the values of any number which is between minus 1 to 0 to check the sign of this. So either you can place over here or here. So if I take a value which is between minus 1 to 0, say 0.5, what I'm going to get this as, this is negative, this is negative, and this is positive. So that's positive. So we'll say that we are going to get x cubed minus x as positive. For a value between 0 to 1, 0 to 1, this should give you negative. So I can write minus of x cubed minus x. And for it is greater than 1 but less than 2, that the next limit is this, right? We will get this as over here, that is positive. Yeah, we are getting positive. So this is positive x cubed minus x. So now I'm going to split this function, and I can write this as for the first limit, which is what? The limit is minus 1 to 0. We are getting positive of this, that is x cubed minus x. The next we are getting negative, so I'll put a minus sign first, and then it is 0 to 1 and x cubed minus x. Make sure you have minus sign you put outside. And lastly, it is 1 to 2. This is positive, that is x cubed minus x. Right. So we got this. Next, we have to find the integration of this. This seems to be easy only. Integration part. This is I is equal to, this is x raised to the power 4 over 4 minus x raised to the power 2 over 2, and the limit will be what? That is, the first is minus 1 to 0, right? Then the first one is minus 1 to 0. The next is It's same only. We have a minus sign and this is the limit over here is different. So it's going to be x raised to the power 4 over 4 minus, I'm solving this part, over x squared by 2. The limit is 0 to 1. And finally, the same thing over here, that is x raised to the power 4 over 4 minus x squared by 2, and the limit is 0 to 1. So now let's solve this. If I place the limit, the upper limit is what? 0 here. So placing x as 0, we are going to get 0, right? So we'll get 0 and a minus sign over here, placing x as minus 1. So this is positive 1 over 4. So this is 1 over 4 minus, again, x placing x as minus 1, that is will give you positive half. Check for the next one. Next time you are going to place x as 1, so it will give you 1 over 4 minus 1 over 2. That's for the upper limit, and lower limit clearly it is 0. Right, it's minus 1 to 0 and then 0 to 1, and the last I made a mistake. Last was, it was 1 to 2. So this is what we will place a plus sign over here. If I place the upper limit as 2, 2 raised to the power 4, right? 2 raised to the power 4 is how much? 16 over 4 minus 2 raised to the power 2 is 4, that is 4 over 2. That's upper limit. And placing the lower limit as 1. So it will be 1 by 4 minus 1 by 2. Now check if I open these brackets, all brackets over here, what we will get? I is equal to 0 minus 1 by 4 plus 1 by 2. Next, if I open this bracket, this is negative 1 by 4, positive 1 by 2. And if I open the last bracket, that is this one, this is 16 over 4. 16 over 4 is 4 I'm writing, and this is minus 2 I should write. Then opening the bracket, this is minus 1 by 4 and positive 1 over 2. Now check what getting cancelled over here. So let's see, nothing is getting cancelled. As I can see, they all have the same sign. So I need to add them. So this is, if I see that this is 1 by 4, 1 by 4, 1 by 4. So it's going to be minus 3 by 4. This is 1 by 2 plus 1 by 2 plus 1 by 2 is what? 3 by 2. And this is 4 minus 2 is 2 only. The last step of simplification should be what? If I take LCM over here, right, multiplying by 2, this is how much? This is positive 6 minus 3. So that is 3 over 4 for this part. 3 over 4 plus 2, and 4 into 2 is 8. That is 11 over 4 should be the final answer. This way we can get the answer of this question. And the next question is to evaluate this for the limit minus 2 to 2. Now, one thing is very clear that we cannot apply the direct integration over here, as we know that this exponential function is in the denominator. So to eliminate this exponential functions, what we are going to do is to apply this property over here. And the property is what? Fa to b, fx dx can be written in integration fa to b, a plus b minus x dx. As you can see, minus 2 and plus 2 will get vanished, and that results to give you this in negative and this is negative. On adding, we can get the result. So let's proceed with this. I mark this as equation 1 only and say this is I is equal to. So if we continue writing this is by applying the property, we can say this is the numerator will now become a plus b minus x. A is what? A is 2 minus, and b is plus minus is minus, right? Minus b. And make sure you're writing the square outside, right? The square is over whole x. This is x square. That whole divided by 1 plus 5 and raised to the power once again a plus b, and b is minus, right? Minus x. And say dx. So this is minus 2 to 2. So over here you can see that this minus 2 plus 2 get cancelled. So is this plus 2 minus 2. So we'll get minus of x square is what? Positive x square. And this is 1 plus 5 raised to the power minus x dx. Now I'm going to simplify it over here. I is equal to minus 2 to 2. And this is x square over. I'll write 5 raised to the power x as 1 over 5 raised to the power x dx. This is minus 2 to 2. And if I take LCM, right, this LCM 5 raised to the power x can be written in the numerator. And over here we'll get 5 raised to the power x plus 1, or I can write 1 plus 5 raised to the power x. I did nothing. I took LCM over here and transpose this LCM denominator in the numerator. And we have an x square. So I'll write x square and then dx. Now check if I write this as equation 2, and you know what is equation 1 over here, this being the equation 1. So if I add these two equations, that is adding 1 and 2, we'll get on the left hand side as 2 times I, right? So we'll get 2 times I on the left hand side. The limit is going to be minus 2 to 2. This is what? The numerator is what? X square over 1 plus, right, 1 plus 5 raised to the power x. And adding, let's check once again. On adding, we have the same denominator, right? Let me show you. This is the same denominator over here. So the denominator remains same. That is 1 plus 5 raised to the power x. And the numerator, if you add, check the numerator. Numerator is what over here? This is x square and this is 5x square, right? So this is x square plus 5 raised to the power x times x square, right? So if I take x square as common, minus 2, I think we can do it here only. So as you can see the working on a single page. This is 2 times I is equal to integration minus 2 to 2. If I take x square common from the numerator, it should give you 1 plus 5 raised to the power x square over 1 plus 5 raised to the power x. So this get cancelled. So we are left with just x square over here. And evaluate this. So now this is 2 times I on the left hand side. The integration of x cube is what? X raised to the power 3 over 3, right? And the limit is what? Minus 2 to 2. So this is 2I is equal to, and placing the upper limit as 2, 2 raised to the x raised to the power 3 is what? 8. So it's 8 over 3 minus the lower limit, and lower limit coming as minus 8 by 3. So it should be plus now because minus and minus. So 2I is what? 8 plus 8, 16 over 3, right? So 16 over 3. Finally, I can cancel this to get I as 8 over 3. Now, that should be the final answer. In this question, we have to evaluate this function for the limit over here is 0 to pi by 2. Now, first thing that we will do here is to get rid of this x by applying the property. As you can see that this cannot be integrated without eliminating this x. So for that, we'll be applying this property, that is integration limit 0 to a f x can be written as integration 0 to a f a minus x. That means wherever there is x, we are going to write pi by 2 minus x. So I will consider this to be 1 only. Let's say this is this is equation 1, and this is I is equal to. So now straight away we can apply the property. This is 0 to pi by 2. Well, a is pi by 2. So x can be written as what? Pi by 2 minus x. As I said, wherever there is x, it should be pi by 2 minus x. Now rest will be same, that is sine x can be written as sine pi by 2, not written as. I'm going to apply this property, that is applying a minus x. So cos x will be replaced with pi by 2 minus x. This is pi by 2 minus x. So will happen in the denominator. This is sine raised to the power 4x, and x will be pi by 2 minus x. Lastly, it is cos raised to the power 4, which can be written as cos raised to the power 4 pi by 2 minus x. This is I is equal to 0 to pi by 2. Now, what you need to understand, yeah, let's write down this first. One more step. This is sine 90 minus theta is what? Cos theta, right? So this is cos x. Similarly, cos 90 minus theta is sine theta, so that is sine x dx. And below, same, this is because this sine raised to the power 4, and this is pi by 2 minus sine 90 minus theta is cos theta, so that is cos raised to the power 4x, and this cos will become sine. So now what you can observe that if I add these two equations, let's say I mark this as equation 2, on adding 1 and 2, there is something coming common. This part, right, this is common. That means taking these as common, if I add these two equations, so this is 2i. So I'll just write out the common part first. And let me write down the common part first, which is sine x dot cos x numerator dx. And this is cos raised to the power 4. Well, order does not make difference in positive. Sine raised to the power 4 plus cos raised to the power 4x. And then ultimately we are going to add x with pi by 2 minus x. So if I show you, if I add x plus with the other pi by 2 minus x, this get cancelled. So we get pi by 2, and that pi by 2 I'll write over here. This is what you will do. Now, next is to apply substitution. And for applying substitution, we are going to consider, first I'll convert this cos into sine so that we can consider sine square. Let me tell you why I'm looking for sine square as t, because if I get sine square as t, I'll get 2 sine x dot cos x dx is equal to dt. And this way I can replace this with dt. So this is the reason I am going to convert the denominator cos as sine. So this is 2 times I, and I can isolate this I. Instead of writing 2 times I, I'll be writing I transposing 2 to the other side. That's why it's going to be pi by 4. Right, it was pi by 8, now it's become pi by 4. Integration 0 to pi by 2, and sine x dot cos x, and this is sine square. As I said, sine square, I'm going to take sine square x as t. That's why I wrote power 4 as sine square whole square plus. And what I can write this as? I can write this cos raised to the power 4x as what? I can write this as cos square whole square. And cos square can be written as 1 minus sine square. Now, as I said, I'm going to consider this as t. Taking this as t, I'm getting this as dt. So from here, you can figure out that I need a 2 over here. So that's why I'll multiply divided by 2. So I can replace this whole thing along with the dx. Where is dx? I can replace this whole thing along with dx as dt. So check what will happen. This is I is equal to, now it's pi by 8, right? Integration. But the limit will also be changed. I'll change the limit later. And I'm going to write this thing as dt. So 1 over, this is t square. This whole thing is t, right? This whole thing is t. So there's a square above. That's why it's t square. And this is 1 minus, this whole thing is t. So this is t and then whole square dt. Now for changing the limit, here, right? So there's no use of this. I can erase it now. So when I take limit as 0, so when x is equal to 0, sine 0 is what? Sine 0 is 0. And when x is equal to pi by 2, sine pi by 2, right? Sine pi by 2 is 1 and 1 square is 1 only, right? So therefore, t is equal to 1. So then the limit will now change and the new limit will be 0 to 1. Now from here, what we'll do? Partial fraction? No, completing the square will be applicable. This is pi over 8 integration 0 to 1, 1 over t square. Expanding this, a plus b whole square, a square minus 2ab plus b square dt. This is pi over 8 integration 0 to 1. What I can write this as t square plus t square is 2 times t square minus 2t plus 1 dt. What next? We will be dividing it by t before applying the before completing the square. So it should become what? First I'm multiplying half. So dividing by 2. This is dividing by 2. So this on dividing by 2, what we are getting? This is t square minus t plus half. So this is I is equal to, now it's pi by 16 integration 0 to 1, 1 over. This is a square minus 2 times a is what? A is t. And what should I write b as? B has to be half, right? So as to restore minus t plus b square. And this half should be copied. And as you can see that I have added a half square, so I must subtract half square, which is 1 by 4. This is 1 by 4. And this is dt. So now I is equal to pi by 16 integration 0 to 1, 1. And this part is going to be a minus b whole square. That is t minus half, right? T minus half whole square. And on simplifying, this is what? Half minus 1 by 4 is positive 1 by 4. So this positive 1 by 4, I'll change this. I'll change it as 1 by 2 whole square. Well, I'm getting 1 by 4 from here, which I'll write like this. Now, why should I write like this? Because I'm going to apply the relation, that is, the relation is the property, right? That is x square plus a square integration. Which is what? Tan inverse x 1 by a tan inverse x by a. Should I write? Okay, I'll write it. We know that integration uh, x square plus a square is what? 1 by a tan inverse x by a. This is what we are going to apply. So this will be as it is. I is equal to this pi by 16. Yeah, that's pi by 16. Pi by 16. Have I modified? Yeah. So this is pi by 16. 1 by a, and a is this. So 1 by a. 1 over half is what? 2 only. And tan inverse x by a. Well, x is this. T minus half, whole thing is x by a by a is this, right? So integration part is done, and now placing the limit 0 to 1. So I is equal to, now it will be pi by 8 on dividing this. First I'm placing the upper limit. So this is tan inverse, placing x as 1, sorry, t as 1. So 1 minus half is what? Positive half, and below we have half. Make sure you understand this as part of an angle. Minus tan inverse, placing x t as 0. So this is 0 minus half is minus half over half. I is equal to pi by 8. This is what? This is 1, right? This is 1. Tan inverse 1 is what? Pi by 4. This minus sign is copied over here. And this is tan inverse minus half is minus pi by 4. So this is I is equal to pi by 8 minus minus plus. So pi by 4 plus pi by 4 is 2 pi by 4, which is pi by 2. So we get I is equal to, this is pi into pi, pi square over 16 should be the answer for this.